We are your home theater and AV questions answered. This is AVRant. Want your home theater or AV question answered by Tom and Rob? Send it to question@avrant.com. Welcome to another edition of AVRant. I'm Tom Antry, and I'm here with
Rob H. This is AVRant. It's your home theater and AV questions answered, but this particular episode is an interview episode that we're very happy to present to you. I'll let Tom make the introduction because, we're excited about this one.
We are very excited about this one. But before we tell you, you know who it is. It's in the title. So, Todd Welti, very well known from the Harman Research Group and all the subwoofer placement suggestions we come up with. They all come from his research, which you will learn a lot more about. I was very excited to learn about it. So before we get into the podcast, though, let's go ahead and give our contact information. This is AVRant. It's the podcast that answers your home theater and AV questions. Every week, we take all of our listeners' questions, and one at a time, we answer them. That means I don't know where to put my sub. We use Todd's research to tell you where to put your sub. If you don't know what speakers to buy, you give us some parameters, and we help you narrow down your choices. You don't know what size screen or what screen material or what display type to buy? We help you with that. Your room doesn't sound right? We'll help you with that as well. You don't know what movie to play and impress your friends? I mean, we'll help you, but come on, man. There's a Google search for that one. So, AVRant. You can always get your question answered here by emailing us at question@avrant.com. You go to www.avrant.com and click on leave us a comment there, facebook.com/AVRant podcast. Our videos are up at youtube.com/AVRant. If you want to contact Rob directly, it's rob@avrant.com. His Twitter's @FirstReflect. I'm Tom @avrant.com. My Twitter is @avrant_Tom. So with that, and without further ado, let me just go into the pod. Just roll the tape. Well, I want to welcome Todd Welti to the podcast today. He's very graciously agreed to do a short interview. We told him short interview. He's obviously never listened to the podcast before, so he doesn't know what he's in for. But Todd, of course, is no stranger to this podcast. His name has been mentioned many, many times in connection to the Subwoofer Placement Whitepaper that we talk about over and over again. So I want to welcome Todd Welti to the podcast. Welcome, Todd.
Thank you. Happy to be here.
So let's just get right into it. Let's go ahead and introduce yourself. We know what you've done in the past, but what are you doing right now? What's your current position with Harman?
Currently, I'm a distinguished engineer at Harman. Just celebrated 20 years at Harman. So it's been a long-term gig for me. Worked my way up, and pretty much all that time I've been doing acoustics in one form or the other. It's been a great job. I love working for Harman. I mean, I couldn't say enough good. I got to work with Floyd Toole and Sean Olive, and still working with Sean. And we got a whole new crop of wicked smart people there that I'm still learning from. So it's been a great gig. I mean, I love it. So
I'm already going to go off script here, but can you tell us a little bit about your background, like what your training and stuff like that? How did you get into the audio side of the AV world?
Right. So I got out of school with a degree in electrical engineering, and I was essentially looking for a job, and I went to this headhunter, and he goes, "Well, I know this guy. He's in acoustics, and he's looking for someone." And I said, "Okay." So I interviewed with him. He liked me, and I said, "Cool. It sounds like there's definitely some overlap in the mathematics of it, and there's a lot. I like acoustics, but I'll just mention that because I was not, like many of your listeners are probably people who were always interested in audio since early age, and they got to it that way. I kind of stumbled into it, but once I was there, I loved it, and so I was an acoustical consultant for almost 10 years, and that was a great job. Got to do all kinds of things. I never knew where I was going to be next. Crawling around in the bowels of a building making measurements, or making measurements of a dog's barking, or whatever it was always different, and I cut my teeth on acoustics there. at some point I decided I want to go back to school. So I went back to school in Denmark and got my master's. And then I was looking for a job again. I saw a job advertised by none other than Floyd Toole and Sean Olive. And I'm like, I know these guys. I referenced them in my thesis. I've been looking at their papers for years. And again, I just went, interviewed, got the job. And I've been a pretty lucky guy that way. Just kind of fell into it. But then, then now 20 more years at Harman doing, again, a lot of different stuff. I'm so glad that I didn't have to just do one thing for the last 30 years.
That's awesome. Well, one of the things that we always do here whenever we have a new guest on AVRant, we always like to ask what you're running in your own system. You let us know beforehand that you don't have a full dedicated home theater going right now, but that is totally fine because we got everybody from people going with just a pair of Bluetooth speakers to all the way to, multi-$100,000 theaters. So we'd love to know what you're rocking.
Right. Yeah. As I mentioned, I don't really have, my situation doesn't really allow for like a dedicated home theater. I had one some years ago. It kind of, I haven't really updated it. Right now, I'm actually testing out a JBL Bar 9.1 that I got from work. So I'm sort of doing an evaluation on it. So I've got that set up. I also, just due to convenience, and I do a lot of headphone listening. I also spend about most of the last 5 years doing research on it, so I'm no stranger to headphones. But I've got a AKG N5005. I've also got a JBL Quantum One, which has Quantum Sphere. It's so it's got this 3D. Using HRTFs, and it's actually, I know it's a gamer headphone, but actually the sound quality is pretty good, and I actually like that. And if it's not quite the way I want it, I've got a mini DSP, IL DSP, little about the size of your finger, and you can program it, parametric filters, whatever you want. So I do a fair amount of listening with that.
You came to the right podcast to talk about this stuff.
Oh, really? Are you guys big fans?
Everybody knows what you're talking about. You said mini DSP, and everybody else is going, did he just make that up? No, yeah. Everybody knows what you're talking about on this podcast.
Yeah.
Just to warn our audience, I mean, we already know we're probably going to want to have Todd back to talk about headphones, but this first interview, we're going to focus on the subwoofer papers. So keep that in mind for perhaps in the future, but don't want to disappoint anybody that just for time reasons, we're not going to dig into the headphone research today.
I could talk about headphones all day. Let's talk about headphones.
Yeah, we could spend a couple of hours on that, I'm sure. Yep.
So like we said, we are going to focus on subwoofers. This is an uphill battle we've been fighting since we read, the white paper. So I mean, we call it the white paper as if there was only one, but that we read the subwoofer placement paper and really blew our minds as far as how placement and locations and number of subs and all of that, and changed the way that we really view and suggest how to place subwoofers in somebody's room. And it has informed us as far as how, Rob has written a 12-step guide to how to place subwoofers in a room that isn't a rectangle. That isn't a perfect rectangle like the one that in your paper, but and it's all based on how you guys did your research. So to start with, what brought you to write this research the topic and write about subwoofer placement, and what got that paper started? What was the impetus there?
Yeah, I mean, I just started at Harman. It was one of the first things I worked on, and there's a company called California Acoustical Technology. I don't know if you guys are familiar. I think they're still around. I used to always see them at CEDIA and whatnot. And back in the early 2000s, we went to CEDIA, and they had this setup, this room, and they had something 22 subwoofers all flush mounted in the wall all the way around. And Floyd and I were looking at it thinking, wow, that's amazing. I mean, but is it for real? Is there really, any advantage to be had in having so many subwoofers? I mean, if there is, great. We sell subwoofers, but if not, then we don't want to. I don't like the idea of selling people things they don't need. So Floyd just basically said, you know what? Look into it, and I'll give you full carte blanche. Do whatever you want, and I had no idea I was going to, spend that much time working on it. But basically, Floyd wound me up and pointed me in the right direction, and that's what got me started.
One of the we're not going to necessarily dig right into the content of the paper itself because it's publicly available. We're going to have the link for the paper posted in the show notes, so anybody can read through it and dig into the details of the paper itself for themselves. But I mean, the conclusions are posted right there at the end of the paper with very practical, easy to follow suggestions for what you should do. That 2 subwoofers is clearly better than 1 when they're optimally placed. 4 subwoofers is basically ideal, but there's an obvious benefit going from 1 to 2 that is massive. Were there any surprises that came along out of the research for yourself? Did you come in with any sort of preconceived notions and then that changed over the course of doing the research?
Yeah, there were a couple. At first, I want to point out though that paper that you're talking about is, it's basically a white paper derived from the AES paper.
Right.
Right. I mean, I'm sure you're aware, but maybe your listeners don't know. And it used to be you had to pay for it. I think
there's still a paywall for the AES papers.
Is it?
The AES one still has a paywall.
Some of them you can get for free, and some you can't. But if you can get your hands on it, that includes everything. The white paper was, simplified and whatnot. So, but I mean, most of the information's there. I guess one of the things that surprised me a little bit is, I did all this modeling. I had to write up a MATLAB script to model these rectangular rooms, and I did that, and I did all this modeling, and I came up with these results, and then I said to myself, well, does this hold up in real rooms? So of course, we got this room. I'm actually still making measurements in that room today, for work that I'm doing now. So I went in there and we purchased. Was it 16 or 18 Infinity Entra subwoofers, put them in there. And so we had this, we tried to replicate at least some of these configurations in a real room. And then there were some that were a little bit different because there was some equipment in the room that I had to go around. But anyway, so we had all these real room configurations. And then when I look at if I try to measure in one particular spot and model that particular spot, I've tried this several times. You're not going to get, it's rare that you're going to get a response that matches that. A lot of times it looks quite different. So, but I was a little bit pleasantly surprised that when I did a bunch of locations and tested the overall, if I compare the configurations, I get kind of the same result as I did with the model, even though the individual locations may have differences, but the seat-to-seat variance, which is what I was interested in, basically tracked in the real room what I got out of the model. So I was very happy because I thought, if this doesn't track in the real room, I just wasted, the last year of work or whatever. But it did track. There's one other thing that I don't know whether to get into it now, but we may get into this a little further down into the discussion here. But I'll give you a little teaser. I'm sure you've all heard that square rooms are bad.
Yes.
Yep. That has definitely been said.
That has been said. It's the first thing you hear when you get into this. Square rooms are bad. And some of my later research, I found some instances where it's not always true. Let's just put it that way. And I'll leave it at that. And remind me later when we get into that. I will explain that in more detail.
Rob, write it down. We're gonna forget. Okay.
I'll keep that one in mind.
We're gonna be too focused on getting through all these questions to remember that.
Right.
So, yeah, that's all right. So, where you sit in the room, there's some like rule of thumb. I guess old wives' tales. Don't sit in the middle. You sit about a third into the room, either from the front or back wall. Sitting on the back wall is bad. How important is the audience's location when you're modeling and you're having these subwoofers in the room?
I mean, yeah, it's extremely important. I mean, it's as important as the location of the subwoofer, because if you look at the equations that we use to model these things, the subwoofer location and the listener location are basically, they're two different terms, but mathematically they're the same. So the effect of moving the source around is equal to the effect of moving the receiver around. So if you think of it that way, of course, it's very important. And you mentioned subs at the back of the room, and of course, when you move near a boundary like that, you will get more bass. Not just certain subs, you'll get more bass overall. That's some people call it the Waterhouse effect or whatever. It's this huge bass boost that it's below. It depends how close you are and whatnot, but it's this huge bass boost, and then it drops off, and then there's this little wiggle. It's kind of like a filter. It looks almost like a filter skirt or something. But anyway, yeah. So if you're sitting at the back, you will get this big boost. And if you have, if you just had the one row at the back, well, maybe you'd get some free bass, and maybe that's not such a bad thing. But if you have several rows of seats, then you've got this huge difference. And I'll take this opportunity to emphasize something. I've had so many times people come up and asking me these questions and get in this conversation only to find out that their room only has one seat.
Right.
So I was like, well, we just wasted the last 20 minutes because all this research only applies to multiple seats. That's the whole central tenet of this thing is multiple seats, more consistent. So
well, just to expand on that a little bit, because we definitely have people who have 2 or 3 rows of seats, and that back row of theirs is right against the back wall. So when we're trying to achieve uniform response across all of the seats, but one of the rows of seats is right against the back wall, is it even possible no matter how many subwoofers you use, or what does the research say on that topic?
I think this Waterhouse effect that I was talking about, that's kind of universal. That doesn't really depend on where the subwoofers are. So I think if you have a row of seats in the back, you're going to get, more bass. I guess the good news is it won't be necessarily like at one frequency. It'll just be kind of an overall, there's more bass in the back. And maybe that's not ideal, but if somebody likes more bass, they sit in the back, I guess. But
well, I guess sort of the bottom line practical advice is if you really want the most uniform for absolutely everybody, then you're going to have all your seats away from the boundaries.
Right.
But if you care more about the front row than you do about the back row, which is definitely the case for a lot of people, then sort of focus on the front row, and then the back row, maybe it gets something a little bit different, but it's not going to be terrible.
Yeah, think of them as bonus seats that maybe they're the last to fill up, but maybe somebody enjoys the extra bass they're getting. Another thing is to if you're not one thing about the back I was going to mention that not having to do with bass, but you can get these early reflections from the rear that can muddy your imaging. So some diffusion at the back would be a good idea if you're going to do that.
Good.
But other than that, you got to watch your first and second order nulls. This is this napkin mode drawing thing that I'm sure most of you and your listeners have done before, but you can pretty easily sketch out where the first and second order nulls will be,
just based on the dimensions of the room.
Exactly. It's just a fraction, and so you can try to avoid those, but the thing to keep in mind is that those may or may not be there depending, if you put one sub in the corner, all those nulls are going to be there. But if you put 2 subs strategically, some of those nulls will not be there, some will. Right. And so you have to kind of think about that. And I think, you could move your seats, a foot and a half this way or that to try to avoid those. And this is discussed in the some of the CEDIA documents that I worked on, where we had some plots of that. And, I think we said move it like a foot and a half. We didn't. I don't know. I had to come up with a figure for that. But more than a few inches, but maybe less than a couple of feet would be enough.
One of the biggest upgrades we often recommend on this podcast to people is moving their seats a few feet forward. You're out of the middle of the room. You're closer to your screen, which you're wanting to get a bigger screen, but you can't fit a bigger screen. So just move closer, and now it's bigger. Right. And then acoustically, it's better for you as well. Right. So this is something that we talk about. And the same thing, as you were mentioning before, if you've only got one seat, then you don't need to worry about any of the rest of this, because we just placed your one sub in the best place for that one seat, and Bob's your uncle, you're done.
Yep. Exactly.
Tom, did you want to take the diagonally
opposite
corners? 'Cause that's your favorite topic.
Yes, it is true. So we frequently suggested diagonally opposite corner placement. We understand that midpoints of the opposing walls is the top recommendation, but the real world measurements included in the paper were one of the few instances where base measured better than the modeling had predicted. So can you talk a little bit about diagonally opposite corner placements?
And this is with 2 subs in particular, because of course financially it's easier to afford 2 subs than 4.
Right.
I went back and looked at the paper, and I'm actually not sure where it shows that. Yeah, I
we
mean,
were
I looked.
looking at the like seat to seat variation, where
Yeah.
it what like the overall shape of it was the same, but it wasn't quite as severe as the modeling in as far as seat to seat
Yeah.
variation when it was two subs diagonally opposite
Okay.
corners.
I don't know. I mean, but there's one point that I'll make that might be sufficient to answer that, and that is, and it's a very important thing. You know, that paper, essentially, most of the work in that paper revolves around one particular room, which is the Infinity listening room, which I mentioned already that we're
Right.
still using. And there was at the very end, I made an attempt to look at some different dimensions. So I think I modeled 5 different room dimensions. But the underlying fact is that we have to be careful what conclusions we draw from that, because it's just a single room, and these all, you know, the room dimensions are definitely a factor. And that, again, I'll drop a little teaser. You know, if we have time to get into it, I did a later study where I tried to address this.
Okay.
So just that's a caveat for that whole paper, is that it was just the one. You know, many of those assumptions were borne out in the later work. So it's not all, you know, it's not wrong or whatever. But with respect to that particular question, that could be an issue, is that you know, just that one room, maybe that happened to be the case. But
all right.
yeah.
Okay. So I wanted to dig into some of the sort of maybe misconceptions or just things that we frequently come across that we think could use some clarification. One of them is the notion of you have 2 or 3 or 4 subwoofers. You have one seat that you care about more than the rest, and so one approach is to time align all of the subwoofers to that one seat, and then go from there. Also, level matching, making sure, you know, if one seat is you know, closer to the back of the room than the front of the room, which is common, that they're not going to have the exact same level if you measure one subwoofer at a time. So should we time align our multiple subs? Should we level match our multiple subs?
That's a good question. I went, you know, okay, let's start with the time align. I've wondered about that a lot over the years. And so I went back just a few days ago, and I'm sure your listeners are familiar with Room EQ Wizard, right? I mean, everybody's using it. And they've got this room simulation module, which is fabulous. I love that thing. You can actually drag the source and receiver around, and in real time you can see these. It's hypnotic. I mean, I love playing with that thing. So I went in a couple days ago, and I just tried, you know, turning, as they have an option where you can time align the subwoofers, right? So I put some subwoofers in, I picked a location, I tried aligned, unaligned. I tried this with several locations, and it actually, I was a little bit surprised. It did seem to help, and the reason I say that I was a little bit surprised is that the way I think of rooms is you know, I don't think of there being like a direct wave coming from the subwoofer. Like at higher frequencies, yes, there's this, it's geometric acoustics, there's a direct wave. Time alignment it's obvious and, you know, thing to do. At low frequencies, I tend to think of the room as more like a lumped element system, where, you know, it's the wavelength is so long that you really can't think of it that way. And then in that case, you know, the response and the phase everywhere would depend on exactly where the subwoofers were. And it wouldn't be so simple as just, you know, the distance. So I was kind of expecting that I wouldn't see much improvement, but you know, there was some. Maybe in that room, there was enough direct, you know, the element from the subwoofer
was that time aligning, like the improvement was seen at the one seat though, or did it apply to all seats?
No, in you know, what you can do is you can put these outlier seats left and right, forward and back, up and down. So I spaced those out, I think at like a meter or half a meter or something, and I tried to visually look at the seat to seat, because of course that's what I'm interested in.
Right.
And it did seem a little bit, you know, it wasn't at every seat and wasn't universal, but I thought, you know, if I spent some time on this and, you know, tallied a bunch of these up, it seems like it may. So, and I mean, it probably can't hurt. Another thing though, like also with the level matching, if you're going to do, like, if you have a rectangular room and you're going to do some prearranged configuration, you know, like midpoints or whatever it is, those are all assuming that these are identical subwoofers, identical gain, and identical delay. So in that case, you would not want to do that, or at least at the start, you would want to have them entirely matched, put it in. Then, of course, after that point, if you wanted to try fiddling around with it, by all means,
that can be a seemingly never-ending rabbit hole.
Exactly. it's exponential. Yeah. Yeah.
So for many years, and still to this day in some circles, the commonly held notion was that full range speakers for every channel was the ideal. So what does your research tell us about that?
Mm-hmm. Yeah, I mean, this subject comes up all the
Right.
time. Again, at Floyd's direction, back in, I don't know, 2005-ish, I think, or something, I did a study in the Infinity Room again, and I set up like a left and right full range system as like a reference, and then I set up some alternate systems which were using bass management and with like 4 different subwoofer configurations. So, option A is stereo bass with left and right speakers at your normal, locations that you might have, and then I compared this to these other bass managed systems with different configurations, and I went to great lengths to select materials which would, have information at low frequencies and left and uncorrelated basically signal in left and right, so that there's something for the stereo bass
Yeah, it's
to
not just a mono
hear.
LFE signal.
Yeah,
for everything.
exactly. Yeah, I got these clips. We used trained listeners. I gave them a chance to listen a little bit to familiarize themselves. We basically took every possible step to sort of weight this thing towards that, whether they could detect it. And we used a very sensitive 3 alternative force choice paradigm, which I was
ABX.
told that, yeah, it was similar to ABX. I was told in school years ago that if there's any difference and you do this test, you're going to be able to detect it. It's extremely sensitive. And basically, after all that, what I found was that for most of the programs that I tested, they really couldn't hear a difference. There was one where they could hear a difference, but that was a contrived signal. This was a warble tone that I got from Dave Griesinger because he was looking into this at the time. And with the warble tone, which again, it's a contrived signal, it's nothing you would ever listen to. They could hear something on that one, but on the other 3 signals, they basically couldn't hear anything. So, that's it. Maybe not definitive, but it sort of made me think that at the very least, it's a subtle effect. And I want to mention, this term, the gorilla in the room. If you're going around in a room and you're moving around and you're hearing, 15 dB difference, in bass from one seat to the next, that's the gorilla in the room.
Mm-hmm.
These sort of subtle spatial effects that maybe you can or can't hear, they maybe if they were the only factor, maybe okay, but you got to fix the gorilla. You got to get the gorilla out of the room first, and then okay, if you want to fiddle around with that's cool. But that experiment sort of put things in perspective for me.
Well, I think that's an interesting one to go just a little bit deeper into, because the next question was about stereo subwoofers, because some people are all about that. That's the only way to do it. And then, of course, we're all about, no, we wouldn't have them put where the front left and right speakers are. We'd have them at the midpoints of opposing walls, if at all possible, if you're in a rectangular room. So, when you get that sort of gorilla in the room issue when you're just using, say, stereo subwoofers or just a pair of full range front left and right speakers. I mean, the research basically says you kind of got to get the bass playing from different locations at that point, right? In order, if you're going to have uniform bass across seats, that you can't just hold fast to this idea of full range front left right and come hell or high water, that's what we're going to stick with.
Yeah. Well, here's something to chew on. Think about this. When you have, if you're not using bass management, you've got your 2 or more, two basically, stereo subwoofer sources. Then we know that when you have bass coming out of 2 locations in the room, that has a very large effect on what the response will be, right? So think about if you have correlated bass from those 2 sources, you'll get one response. If the bass in those 2 is not correlated, they combine in a different way, you get a different response. So while you're listening to the signal, and I've plotted it's a subwoofer paper, I actually plotted left and right correlation as a function of time. And so I was able to see this. And so what happens is that, your response is nonlinear. It's totally nonlinear because it's depending on on this correlation. And so for me, I don't like the idea of introducing a nonlinear system into my bass response.
So if we were to summarize to a rule of thumb, I mean, our approach has been you get a mono signal going to your bass producing elements to your subwoofers. Try to have them properly positioned as recommended in your conclusions, and that is the way that we've approached bass in acoustically small rooms, which is going to be any home theater. And we haven't recommended the stereo bass approach. So
Right.
You're in agreement with that one?
And one interesting thought would be, though, if you could make a system that would basically take the coherent part of the bass and send it to a bass managed system, and then take any part that's not coherent and maybe try to, maybe you could have some fun with that. Maybe there's some traction to be had in that area. That would be a fun thing to fiddle around with.
More sophisticated processing than most of us have.
Yeah, well, yeah. It's not terribly. You can do it. I mean, you can separate them out. Yeah, do like a sum and a difference or something.
Right.
Yeah.
Right. You would have to you'd have to process that on the fly.
Yeah, you'd have to process, and you'd have to make sure that the total, that you weren't mucking up the grand total, bass that you're getting or whatever. But for those people who want to play around with and try these things out, I do it and report back to us.
So I guess we're done with 7, right?
Yes.
We can skip to 8. Okay. So both the modeled and measured results demonstrate the obvious advantages of using at least 2 subwoofers and having them positioned across the room from each one another. But there is the crossover region between the speakers and the subs, where those frequencies will be played by more sources than just the optimally placed subs. So what impact will that have in terms of what the audience will experience? And is there an optimal way to handle that crossover region? Like a steep crossover, slopes, or something like that? What's your take?
Yeah. One way of thinking about all this effort that we're going to optimize the bass, and make it consistent from seat to seat, is that it will make the crossover, a piece of cake, or at least it'll make it easier. Imagine trying to do a crossover where the bass at each seat is different.
Yes.
You can't. Yeah. So, think of it as basically trying to boil this down to like a 1-seat problem. If you just had 1 seat, doing a crossover is, well, I wouldn't say child's play, but it's much easier. So, I like to think of this as a way to sort of approximate a single seat and make
like one really big
something.
seat.
Yeah, exactly. But it's something that you do as a step, to make the subsequent step easier. As far as there will still be issues in the crossover. Good news is that that's a relatively small frequency band. And especially like you mentioned, using steeper slopes to minimize the area in which that's happening. Of course, we don't want to use too steep, or we get ringing. Or there's people that that know way more about that than me, that could go on for hours about Gaussian filters and pre-ringing and audibility. But you don't want to. That's, I think, like 4th order filters or something is probably fine. I don't know. You could experiment around with higher order, but. And one other thought was to keep the crossover frequency, don't crossover too high, because, one thing about all this subwoofer research as far as like localizing is that I've always assumed we're crossing over at 80 hertz, because below 80 hertz, I'm confident. I've done a literature search on it. I've done my own listening, that it's very difficult to hear where the subwoofer is below 80. If you go and stand next to it, you will sort of localize it, but it's minimized. And but above 80 hertz, at some point it starts to get to where you can localize it. And then when that happens, you can't just arbitrarily put subwoofers where you want. Then it becomes a whole different ball of wax.
So into that direct sound that is actually going right from the source to your ear type of thing.
Exactly.
Right. Plus, it's vibrating your couch if it's loud enough.
Yeah. And also there could be one issue that have come up with ported speakers, is that there could be port noises that somehow help maybe make people localize on it or something. I don't know.
It's that distortion. When there's any kind of distortion, the port noise or the vibrating of the couch or anything that gives your brain the cue that the subwoofer next to you is going off. Yeah. That's that really cues you psychologically into something happening there, even if you aren't physically actually hearing it. Your brain's like, okay, these are enough cues for me to say it's coming from right there.
Right. Brain's very good at finding cues, and it, using the best available knowledge that it has to come
Right.
up with a localization.
So we are fully on board with multiple subwoofers. Our listeners are fully on board with multiple subwoofers. But as you've alluded to, the modeling was of an enclosed rectangular room. The measurements that you did are possibly somewhat particular to the room that you use to make the measurements. Obviously, not everybody has an enclosed rectangular room. Some people have a completely wide open grape room. Some people have a room that is enclosed, but it's not a rectangle. So what can be applied from the research that you did to rooms that, are not an enclosed rectangle?
That's a great question, and I'll point out something also, is that a lot of rooms that are physically rectangular may not be acoustically rectangular. And I'm sure you probably know this too. The wall construction, that infinity room that I mentioned is, I think every wall is different. One wall has an extra layer on top for putting insert, wall, flush mounted. One of them has a concrete wall behind it. One of them has a door. So that room is not. I mean, we're calling it rectangular, but it may not be.
It's rectangular.
But anyway, it's physically rectangular. Yeah. I guess one thought is that I've heard it said, and I think it's reasonable, is that if your room is sort of rectangular, could you approximate it by a room? So if you have a fireplace that comes into the room a little bit,
Right.
And if it's significantly, if it's like a third of the wall, then maybe you could count what's the average width of the room, and what can you get with that? I'm a big fan of scientifically testing these things, and that I don't know that that's been scientifically tested, but it seems, in lieu of anything else, seems like a reasonable thing to do. Then you get, one other thing you can look at is, I don't know if you're familiar with the double base array.
God, I mean, I know the term. I'm trying to picture how it goes. Maybe you can give it to help us with the description.
Had some other names, cabs, for example. The basic idea is that you have some subwoofers on one side of the room, subwoofers on the other. You create this wave of a bass, and then you absorb it at the other end.
Right.
And if your listeners are interested in it, there's the more recent good papers. It's called CABS, which I forget what that stands for, but CABS. Some good papers done by some of my students, some guys that were at the school that I went to in Denmark. Did this, my old professor, in fact. Anyway, that's this basic idea. So, that they normally, I've researched it in a rectangular room, but I'm thinking, if it maybe wouldn't work quite as good, but if you had a room that was, at least you had two like opposing walls, maybe you could create this space wave. And so that's one thing. Then, of course, we get into the Earl Geddes approach or any of these approaches which I think you were also going to ask me about it, but
well, we can hop right in, because that flows right into it.
I'll anticipate some of your other questions. So I mean, it's trial and error. It's an intelligent trial and error. It's not just random trial and error, but he's got this method, and he's a smart guy. I'm thinking that what he's attempted to do is to get some sort of orthogonal control over these different modes, get a source which couples into all these different modes so that you have the most control that you can, and then vary this in trial and error. So that's a sort of thing that could work. It would be a great thing, especially for a non-rectangular room. It'd be good. So there's that. Then we could also get into sound field management, which is this thing that we developed after we did this set configuration research. We started asking ourselves the same question: what do we do with these rooms that aren't rectangular? So and also you were going to ask me about this other subwoofer optimization software. I forgot the name.
There's the multi-sub optimizer software, which is a freely available software that it's recommended to use at least 3 subwoofers. 4 is possibly even better, but it's getting into the it sort of came a bit out of the Earl Geddes research and maybe tried to simplify things a little bit for users, but instead of it literally being a fairly complex trial and error process. That the idea is if you measure, position your 3 or 4 subwoofers basically anywhere you want in your non-rectangular, non-enclosed room, spread out, but basically anywhere you want. Then measure each of them one at a time. and then take that response and apply individual delay, individual level, and individual EQ that has been calculated on all 3 or 4, together to try and get the most uniform response you can across the various measurement positions and eventually the various listening positions. It's pretty complex, but the idea is that it's simpler for the user because you're basically just measuring each subwoofer one at a time in multiple spots, and then let the software crunch the numbers and try to come up with unique level, delay, and EQ to cumulatively give you a uniform response at all positions. So I don't know if you've done any of that research. It's clearly different than the paper that we're talking about, but we're getting into this stuff that's outside of the realm of the paper.
It's a whole, could be a whole hour-long subject.
Yes.
So that was the next thing we did after this research. We developed, we call it sound field management. And it's as you just described it. The only in sound field management, you measure each source to each seat, right? So if I have 4 subwoofers and 4 seats, I'm going to have 16 individual measurements, and they have to be complex. They have to be impulse responses. So it can't just be an RTA or something. Yeah. And then you put that in the computer, and it basically simulates every possible combination. And so in that way, it is brute force. But when I first thought about, I like the idea of using a mathematical, really sophisticated, direct solution, which there's ways of doing matrix inversion and whatnot that could solve this problem directly. But I've become, quite the fan of this brute forcing because it has some advantages. I mean, it's easy to understand. If you had some coding ability, you could code this up. I almost could imagine you maybe code it up in Excel or something. It's not, it's not complex, and mathematically it takes a little bit longer, but today's computers are so fast. You can, when we first started, I think one of our rooms, we calculated it was 27 million combinations that it had to sort through. And it did it at that time, it did it in like an hour or something, hour and a half, whatever. Now it would be a few seconds or whatever. So, and the brute force is nice because there's no, some of these other methods have parameters that you have to set, like these gradient descent. There's a lot of really, really gnarly sounding methods of doing this, and some of them have like parameters that you have to set beforehand, and that you have to twiddle and fiddle. The brute force is like you just run it, and you never have to adjust it, and it's going to give you a good result. So
and faster than the manual trial and error of listening to sweeps.
Right.
Yeah, way faster.
So I'm going to go back for just a second here and just give some definitions for our listeners, because not all of them are a lot of them are technologically savvy, but we don't all have this on our tip of our tongues here. So the Earl Geddes approach basically is you put one subwoofer in the front corner, one position basically in the midpoint of the back wall or a side wall, and the third position more or less as far away from the first 2 subs as possible, and that includes vertically. And then you adjust the level, phase, and EQ independently for all 3 subs and try to through trial and error, basically, to achieve uniformity through these subs. Now, you did mention the cabs solution. Can you just real quick, you said 2 subs or multiple subs on each side of the room, and then they fire towards each other. Can you describe what that solution looks like?
Right. So, I mean, think of, the simplest case would be, let's think of a long tube, and you've got a piston on one end and a piston on the other end, and you introduce, I don't know if you can see this, you introduce a wave, propagating this way in the tube. Normally, if you just had a hard wall, the wave would bounce back, and then it would bounce back, and you'd have this standing wave set up, and that's what normally happens in a room, based on the length of the tube. And now, if you put a piston on the other end, and you invert the polarity, right? So it's 180 degrees out of phase, and then you also introduce a delay, which is equal to the distance in this tube. So by the time the sound gets down there, you're now introducing a wave which exactly cancels it out.
Right, and the same as the noise canceling function within your headphones if you've got those things.
Yeah, it kind of is. It's the same in a certain way. It's the same idea. So the tricks, of course, we don't listen in tubes. So we have rooms, and
we have more than one dimension. That's the
All right. We're not flatlanders. Yeah, so there are some ways of optimizing, because I'm conconveniently ignoring the side walls and the
Walls
floor
and
and
the
ceiling in this
ceiling and the floor.
plane way.
Diagonals and
So yeah, so there's ways of optimizing the locations of these, and using more than one, maybe using 2 or 4 and putting them at optimized locations to make this work better. But basically, it's almost that simple, and it basically is that simple, and it's very, it definitely works.
I mean, it certainly would get rid of like that. If that is your one worst room mode, then it's effectively getting rid of that. In that one dimension, you're getting rid of that one worst room mode. Yeah.
Yeah, well, I think if it actually works, it would get rid of all room modes, because you don't have a standing wave anymore. You just have this wave it's almost like you're outdoors or something.
Yeah.
Of course, it's never going to work, as ideally as that. But the other thing is possibly it might not be the most efficient, because 2 of your subwoofers are not creating, they're only canceling the other one. So
they're your active noise canceling for that particular thing. Yeah.
Strangely though, when I did some calculations recently, and I looked at it, and it wasn't as bad as I thought it would be. So it's one of my to-do list things is to go back and look at that. Why isn't that worse than it is worse as I thought it would be, or something?
That's a true scientist. He's like, well, this should have sucked a lot more than it does.
Yeah, right.
Let's figure out why it doesn't.
Yeah, no.
Just before we get into Harman and JBL's version of sound field synthesis, one last question, because it comes up fairly frequently on our podcast, is what if you got a great big room? You got 15,000 cubic feet, wide open basement or wide open great room, open to a loft upstairs, something like that.
Hallways.
It ties into, of course, no longer enclosed rectangle of a room. But do we get to a point where it kind of doesn't matter where the subwoofers go just because of the volume of air that we're dealing with and the completely irregular shape? Or do some of these, conclusions still apply that it's still going to matter where you position the subs and the seats?
Yeah, I've been asked that more than a few times.
I'm sure.
And my answer has always been that, as far as I know, when the room gets larger, the room modes, of course, move down in frequency.
Right.
And unless you're interested in the sub infra bass range or something, by the time you get up to 30 hertz and above, there's so many modes all over each other that you can't really do much. I've never actually tried it. The other thing, or I guess I could bounce that back to you as a question. Have you ever heard the sorts of problems that you get in small rooms? I'm sure you've heard them. Have you ever heard those in large rooms? Because I don't think I ever have. I mean, I would be kind of shocked if I moved my head, a couple of feet in a larger room like that, and heard this huge difference.
It's very hard to find somebody that'll take a 15,000 cubic foot room and try to pressurize it with bass too.
Yeah.
The amount of subwoofer energy that you need to fully pressurize that, so that you even get to the point where you're actually experiencing all the bass that you could. A lot of times we just tell our listeners, just don't bother. You don't want to have a subwoofer that big. You don't want to have 2 of them or 4 of them in your room, in this room.
115 dB in 15,000 cubic feet at 20 hertz. That's a lot of displacement.
I'm like, just get some smaller subs and get them close to you, and maybe add some tactile transducers to your couch so that you feel the bass.
Experience has been that there's usually bigger problems, if I can put it that way. Like there's other parts of the audio spectrum where I'm noticing more problematic things than the deep bass in a gigantic volume of air.
Yeah. Maybe in that case, you actually are getting to the point where you do have a direct, I was saying before that I don't think of maybe in a larger, and here's another cardioid subwoofers and that sort of thing. Can you hear me?
We just got a little glitch there, but I think we're okay. Yeah,
we're
okay.
fine.
Sorry about that.
I got a glitch on you a second ago, so I thought maybe,
that happens. Yeah. It's Skype.
Yeah. Yeah. So that's been my take on it. I mean, could be wrong, but
right. So ARCOS, that's the adaptive room correction and optimization system. That's we've just come across a descriptions of it that being as a brute force approach. Like we talked about before. Tell us a bit about it and the theory behind its approach and how it relates to your subwoofer research.
Yeah, well, so ARCOS, basically, after we developed this, I'm surprised you haven't asked me yet, but this sound field management is not, you cannot go to a store and buy a sound field management box.
Right.
It's been, people have been complaining, and my response has always been, well, our job is to create the technology, not necessarily to propagate it. And there are market forces and reasons why perhaps it's not, there's not an SFM box. But what we do have is ARCOS. So basically what they did was they took the algorithm, they recoded it to make it more efficient, because I'm a crappy coder, and they put a nice user interface on it. But basically at heart it's sound field management. So it's exactly the same thing that we've been talking about. It's using brute force. It has some bells and whistles on it, especially around this optimizing the crossover. There's some other bells and whistles that it does, but it's, at heart, and it's basically running SFM. Yeah.
Okay.
Yep.
One thing I wanted to I mean, we've tackled some pretty technical stuff for people who are interested but maybe don't have all the the technical background. So I wanted to maybe. There's always the risk of attempting to simplify, and you end up oversimplifying and creating more problems than you were hoping to solve. But we've basically talked about various ways, depending on the room and the setup that you've got, of achieving more uniform response across multiple seats. That's the overarching idea. And so I wanted to just clarify that once we've achieved that, because that first stage of getting that uniform response doesn't necessarily mean linear accurate bass just yet. That at the end of getting the uniform response, we're essentially going to apply a single global EQ because now that the sound is uniform in all the places we care about, if we now equalize that, then we can get linear and accurate. So I mean, essentially confirmation that we've got that idea correct.
Right. Absolutely. That's as simple as that.
Okay.
Yeah.
However you get there.
Yeah. If you don't have your seats similar to each other, then you can fix one, you'll make it worse at the other. I'm sure you guys are all knowing that. But.
Well, maybe we can make one more clarification, because I did write this, again, trying to simplify for people, a 12-step guide if you're using just two subwoofers. And if you don't necessarily have a rectangular enclosed room where you can put it at midpoints of opposing walls, the approach that I took there is that still trying to get the subwoofers across the room from each other more or less as much as you can, and then using some trial and error, not quite as in-depth as the Earl Geddes approach or the brute force calculation approach, but basically trial and error, gradually adjusting the phase knob, if you have a fully variable phase knob of one of the subs, until you get as uniform as you can across your seats. That in lieu of anything more sophisticated, that's about as good as you can do. I would love to hear your take on whether that's a reasonable thing to do, or if I'm barking up the wrong tree.
I mean, I think it seems reasonable. I mean, maybe you won't find the absolute best solution, but I think if you thought of it as a curve, you'll get 70% of the way just by if you tried 10 different things and one of them was better, maybe you'd get 70% of the way to the absolute best one. The last 30%, maybe it would take you a very long time to get to 27 million different combinations or whatever. But I mean,
it takes long enough already.
I call Rob's solution the pain and suffering method of setting up your subwoofers.
Yeah, right.
But you didn't have to pay anything more. That's why I wrote it.
Well, you have to get a RoomEQ wizard. You got to get a computer if you don't have a laptop, and you have to get a measurement microphone. So there's a couple of things to buy, but it's not that expensive. Not as expensive as it could be.
It was just reminding me of I was trying to remember. This was years ago at I think it was a CEDIA or AES show. This guy had these little capsules, right? And you would put them out in the room, and each one had a microphone on it and a light, and it would basically, it would basically show you where the modes are. You put 20 or 30 of these things out, and it will flash every time, it worked. You could basically visually see the mode, and I was thinking. I would love to get some of those and use them, because then you could, in real time, you could, turn these knobs and see maybe what the effect is. I don't know. That's a random thought of the day.
Well, I promised I would remind you, and so I must. Square rooms. What did we have to say about square rooms that everybody says don't build a square room, or a cube in particular?
Yes. In order to answer that, I am going to share my screen. You might want to edit this part out because it'll take a second to find it.
No problem.
We don't
We're
edit.
quite used to that.
Let's see if this works.
All right, we'll give it a try. We're trying something on Skype here.
Nothing happened. Did you see?
No, we didn't get your screen share just yet.
Oh, okay. Hold on. I'll tab. Right. So close.
Yep.
So close.
We're audio people. We're not computer people. All right. If you want computer people, that's a different podcast.
There it is. Now you can.
There we
We
go.
are seeing something there, and let's see if my OBS manages to capture it, because that's the real question.
Well, I can see it. That's all I really care about.
okay.
Everybody else is on their own.
You should see it by now.
My Skype is seeing it. Unfortunately, my OBS is not. I'll
That's
work
okay.
away
We
in the
can just get a
background to see
picture
if
of
I
it.
can get something going there. Sorry about that.
Or I can send you.
send
you
them
this,
to
and you can.
Yes,
you can
we'll insert the image. Yeah,
later.
that's perfectly the way to do it. Yes, thank you.
Okay. So I have this whole presentation. I'm not going to bore you with the whole thing, but see if I can make it a little larger. So after doing all this work on the paper that you're familiar with, I realized, of course, that that's just one room, and I have to be very careful not to make assumptions. And people do this all the time. They make assumptions based on one room, and it's very much dependent on the room dimension. So I wrote a MATLAB script, which is optimized for modeling large numbers of rooms and large numbers of seats in each one of these large numbers of rooms. So what I'm showing you here is this interface for this thing, and so what I would do is I would tell it, okay, I want you to model every room between 3 by 3 meters up to 8 by 8 meters, every maybe half meter or whatever that. So that's whatever it is, 30 rooms or something. And in each one of those rooms, I'm going to put this cloud of receivers in. So I'm not fixed to particular seat locations, but it's this cloud. And then I'm going to run that. And I'm going to calculate all those responses, and then from that I'm going to calculate some metrics, which is basically the seat-to-seat variance. Mean spatial variance is what it's called in the paper, and also a base efficiency metric. So two metrics: seat-to-seat variation and base efficiency. And I'm going to calculate those for all these large number of rooms, and for each one of those sets, I'm going to try a different subwoofer configuration.
Okay.
So maybe the first time I run it, I just stick a sub in the corner and I run all those, and that's my reference for what's typically done and what probably would be the worst, seat-to-seat variance. Then let's put in the 4 in the corner. Let's put in the wall midpoints. Let's put in, I did, I think, 7 different subwoofer configurations. And on top of all that, if that wasn't enough, I also did 7 different seating configurations.
Wow.
Because, here, this is just showing one seating configuration, which fills up most of the room. But I have other ones where it's only like the back third of the room. I have one where I took out all the seats on the first order nulls, or no, the second order. I took out all the seats on the second order nulls because I've been telling you shouldn't put seats there. So what's the effect of that? And so I have 7 different seating configurations. So I got 7 different sub configurations, 7 different seating configurations. So that's 49 each times whatever, 30 or I forget how many, 50 different rooms times couple thousand receivers in each room. So I calculated all that, and that's quite the information database. So what I get from that is a plot like this. You can see that?
Yes.
So what this is a plot of, first of all, the color is seat-to-seat variance. So anything that's red means there's a lot of seat-to-seat variance. Anything that's blue, if it was like pure blue, like down here, you can see my cursor, right?
Yes. Yeah, we went not in the final video because we're going to just insert the images, but that's okay. It's described pure blue down at the bottom of the graph.
Yeah. So the blue areas would be areas where the seat-to-seat variance is very low. That's what you want. So and each point in this graph is basically a different room dimension. So here's a small square room down by 400 by 400. If I go up diagonally, I get a larger square room, and then on the upper right, I get an even larger square room. These other ones are rectangular, not square, and of different dimensions. So here I could say, okay, what about a 700 by 800 centimeter room? I will go over to this point, and I could look at the color and say, well, that's I could get an idea of how well it performs. Now, this whole plot is for one particular subwoofer configuration and one particular seating configuration. So, as you can imagine, there are a lot of these plots. And
Yes.
so you can look them up. And here's some of the seating configurations I used. Arch. There's with the second order nulls removed. There's the back. There's a back small. These are the different subwoofer configurations I tested. Now these on the lower right are particularly pretty good performing ones as well, which I don't know if that was in the original paper, but. And here's the result after all that.
Okay.
But blabbity blab. So here's the plot. This is the MSV is the seat-to-seat variance plot, and the MOLN is the base efficiency plot. So I'm trying to get. I don't want to throw away my base efficiency, right?
Right.
I mean, I want to have good seat-to-seat variance, but also pretty good efficiency. So these are the two plots similar to what I already described for you for a sub in the corner and a full seating. Okay. So this is just one example.
That's it looks like some pretty bad consistency no matter what you do.
I tried to scale this so that this is bad consistency but good.
So for people on the podcast that can't see all this stuff, basically he's got one sub in the front left corner, almost the entire room about a foot, maybe a couple of feet off the wall, about the width of the subwoofer off the wall. The entire center of the room is plotted as far as
seats.
Each of it being as many seats as you can possibly shove in there. The MSV, which is the seat to seat plot, is very bad, but the base one's not so bad. I mean, the base one looks pretty good.
Basically, the best you can get, with one subwoofer in the corner. So this, as far as this is concerned, this was just not surprising. But the interesting part that I'll point out is look along the diagonal here on the MSV plot. This line here is the diagonal. These are square rooms, right? 900 by 900, 800 by 800, and you see that they are actually worse. So our this idea about square rooms being bad is borne out here. You can see this in the plots. So so now that's that. Now let's go on to the same seating configuration, but now I've got these wall midpoint subwoofers.
So four subs,
four subwoofers.
The midpoint of each wall, still a square room though.
This is still the same room, the same seats. All I did was I moved the seats to the Uber 4 subwoofer, Welti configuration or whatever. And then I make the plot. Now what do we have?
Right.
Now look, MSV is good. Good. The MOL base efficiency is bad. but look along this diagonal on the MSV plot. It's not worse. Right. It's good everywhere. So that for this subwoofer configuration with the 4 subs on the midpoints, square rooms are just fine. Thank you very much. Makes absolutely no difference.
So now we know we have for going forward, if any of our listeners come at us with a square room, we're going to have to tell you to get 4 subwoofers and put them in the midpoints of all the walls.
Right.
So next time somebody says to you, "Wow, that's just square room. That's going to be bad." Well, no, not necessarily. It depends, where you put
how much? What's your subwoofer budget?
Yeah, exactly.
Yes, if they're insisting on only one sub, then the research says it is going to be an issue.
Right.
Right.
So that's that was the surprising thing that I alluded to earlier in our discussion. The reason I wanted to come around to this is that besides that one little example, I've compiled all of this data. You can get to it on the Harman website. You can also read the paper, the AES paper, which has a long title, which I can't remember, but
it is very long.
Let me just quickly. Well, that's not it. Well, I had a shorter title for this presentation version, but anyway, you can find it, or you can email me. I'll send it to you or whatever. This information exists, and surprisingly, I think this is way cooler than the original work because it addresses this thing about different rooms. But I got a surprisingly weak result to this, and I think it's because people, they don't want they just want to be told where to put the subwoofers and be done with it. They don't want to just tell me where to put the damn things and I'll be on my way.
Yeah. Well, and that's something that I think we're still dealing with a lot of people as far as subwoofer placement, in that you get people who will go to the manufacturer's website and they'll see pictures on the website of the subwoofers, like, man, I want my system to look like this. And the subwoofers are always at the front of the room, flanking the front, left, and right speakers. Well, is that because it's the best place for them? No, that's because it's very hard to take a picture of two subwoofers in opposing walls.
Right. Photo.
Yeah, that's 360-degree camera.
Yeah, that takes a 360 camera view that doesn't really exist. So yes, they want you to buy two subs, and this is how they're going to convince you to do it. So that alone takes some convincing that no, that's not the way we should do it, especially when you go on the forums and there's been this ongoing stereo sub must be placed next to your front speakers,
or the two-channel crowd that says no subs no matter what. That still exists out there.
And it's been going on for so long that people are just like, it's been said so often, it must be true. Like it's just not the case.
It's just not only in home listening, it also exists in recording studios.
Sure.
Other places where it could have an effect on the output could be affected in some way, maybe by maybe the producer's desk has a different response than the engineer's position or something.
Right.
But so I wanted to touch on that, because I think it's by far the most useful thing if we're still in the rectangular room zone. Now, out of this, I can say that even with all these different room dimensions, I did actually, some things didn't change.
Right.
The four side walls overall, with all these different configurations and whatnot, it's still the best. This is still the best for bass output, and the best. These are good ones for combination. If you want a good compromise between seat-to-seat consistency and bass output, and let's say you don't know the dimensions of your room and you don't know where the seats are going to be, then these would be a good bet. But if you know the room dimensions or you know where the seats will be, or maybe you know where the subs will be but not the seats, whatever, I would direct you back to this compendium. You can look it up and get a more specific answer for your specific room here.
Yeah,
okay. So the ones that he was talking about that were very good performers were two subs in the front mirrored by two subs at the back, or two subs on the sides mirrored by two subs on the other side. So if you have two subs in, 2 feet in from your side walls at the front, then, or just say you have them flanking your front speakers, that's fine. Just put two more of them directly across at the back of your room.
Good point. These are at the quarter room dimensions, which should, in a lot of rooms, will be fairly close to where your left and right speakers. So if you want to have that, but then put the two at the back.
Those marketing shots that we talked about, where you got the two subs up at the front, basically right next to your front left right speakers. I'm like, that's fine as long as you got two more at the back. You're not seeing the second picture where there's two more of them at the back. Then you're okay.
Exactly. Right.
Well,
so do I need to unshare my screen?
Yeah, that
now,
would be good. I'm going to try to get back our 3-person image, but we're sadly come to the end of, more than an hour already. It went by very quickly, as we rightly suspected that it would.
I warned you. I'm sorry.
That's right.
And now that if you ever come back on the podcast, we're not even going to lie to you and tell you it's going to be an hour. We're just going to be like, we're going to talk until dinner. Lunch, breakfast the next day. Who knows?
Down.
But just so we aren't remiss, is there anything that we forgot to ask today that you really wanted to make sure our listeners hear about on this particular episode?
I don't think so. The thing we just talked about was the one that I really wanted to get out there. I would say, when you stand back from all of this, use bass management. Choose delays that when you're designing your system, try to come up with a design that gives you control over the delay and the gain and maybe even the EQ of your subwoofers. If you can have some flexibility in where the subs go, that's great. You can move them around. And finally, my plug for when you're doing measurements and equalizing, you need high resolution. No RTAs. I'm not. They could be useful for certain things, but when you get into room modes, you need some high resolution. So go out
You
and
don't
get
like
your
that
free.
1/3 octave smoothing? You don't like that?
It has its purpose. I use that a lot, but for room modes, you should at least be able to see the non-smooth version of it. And
Yeah.
there's no excuse when you can go out and get a free, really cool measurement system like Room EQ Wizard or
Right.
there's some other ones too. So there's really no excuse anymore.
Yeah, it doesn't have to be an arm and a leg anymore. It's not
No.
not ridiculously expensive, especially for people who are spending tens of thousands on their speakers. That's
right.
a drop in the bucket to actually
Right.
optimize the performance of all the stuff you bought.
That's
And
right.
we do want to plug our friend Herb over at Cross Spectrum Labs. Herb offers measurement microphones, which are basically off-the-shelf microphones that cost about $100, but he provides a calibration file individually for that microphone,
Nice.
which he calibrates it to his professional $10,000 mic, sees what the differences are, provides a calibration. You can stick that right into Room EQ Wizards, and I think he charges like a $10 or $15 premium on top of the actual mic.
Wow.
It's ridiculously cheap. So always go to Cross Spectrum Labs. I'm not getting paid for that, believe me, but Herb's a great guy, and I think he's got a great product. So I always like to plug him whenever I can. So I know that we're at the end here, and I got a dog dentist, a dog appointment I got to go to. But I did want to ask you one last question, and it's in here, but you got to get asked, stopped at these conferences all the time, and by enthusiasts like us and other people. What's that one question that you're sick of answering? Like, other than all the ones that we asked today, which I'm sure is on the list. But what's the top question you're like, oh God, don't make me go through this again. What's the one, Todd? Come on.
I'm trying to think of one that we haven't already touched on. I think we've covered it.
Well, now you can point to this podcast and say, hey,
Right.
next, if you want the answer to that question, go listen to an hour and a half of me talking with Tom and Rob over at the AVRant podcast.
No, I don't know if I could think of any that we haven't touched on. The single seat thing.
Right.
That's probably the single biggest one. I get asked a lot about particular rooms, but I don't mind. People. I probably shouldn't be saying this, but this, I get these. They send me, what should I do? And I try to. I don't mind. It's it just doesn't take too long to answer. So, I've always been a there's no dumb questions sort of guy, because I'm the first to ask dumb questions. So, all questions are good. I can't think of anything that we haven't discussed. If I do, I'll let you know, and you can tag it on the end of the show.
We'll have you on again. Well, we got to talk about headphones. We got to talk to you on.
That's
yes.
Yeah.
That's got to happen.
I can drone on and on headphones too, and maybe we get Sean Olive, who or Omid Kansaripour, who we all did that work together. We're all knowledgeable about different areas of it that we
That'd
worked
be great.
on. But yeah.
Love it.
Awesome. Well, if people are watching this on YouTube, we've had your Twitter handle up there. It's at Todd_Welti if people want to find you on Twitter. But is there any other way, if you're willing, people to get in contact with you, or where can people check out your latest work and writings?
I would say you can put up the Todd.Welti at Harman.com. It'll be fine. I'll probably see that sooner than I'll see the Twitter one, because I'm on there every day for work. But and for papers, you can go on AES and get look around. Even if you do have to pay it, I think it's like $15 or something. Yeah. It's not much, is it? I mean, it might be worth getting the paper, or maybe trying to find it if somebody if it's some form of it is on somewhere around. But yeah, most of the stuff that I've done is either in the AES or the ASA somewhere. Mostly AES. Pretty much everything we've worked on has ended up in a paper. So we're, at Harman, we're very, we're trying to assume a sort of a thought leadership position and contribute to this society of whom we have taken so much from, to put some back and all that. So we're pretty open about our research. So you can find
Todd, yeah, I want to really thank you personally for coming on the podcast and talking to us, and for the work that you've done. Especially, I know that we're always looking for those easy answers of where to put the subwoofers, but giving us the knowledge so that we can help convey it to our listeners. That's what we do on this podcast. All we do is answer listeners' questions. So as people email us, and it's almost every week that we get, where do I put my subwoofer? We're constantly using your body of work to help us. And you talking to us, helping to clarify some things, really getting it from the horse's mouth is very helpful for me personally, and I know that's going to be helpful for our listeners.
Right. I'm glad I can help.
So thanks a lot, Todd. Rob, do you want to say any parting words before we
just want to say it's been an absolute pleasure. Very, very happy to have made your virtual acquaintance, since we can't meet each other in person in real life. So it's been wonderful, and thank you from me as well so much for spending the time today.
Yeah, thank you, and thanks for having me on. I actually enjoyed this quite much.
Everybody always sounds so surprised when they say that at the end of the podcast.
Yeah, right. I thought maybe I'd get grilled, but no, I'm just kidding. You didn't grill me. Just good questions.
Thanks so much, Todd. Have a good day, and thanks so much again.
Take care.
Well, that was certainly a fascinating interview with Todd, who was extremely personable and honestly pretty well spoken and very cool for such an obvious engineer. My wife's an engineer, and she is like a unicorn of engineers. She's a great communicator, and she loves to talk to people. And Todd it's very dense, some of the research that he's doing. It's very hard, the mathematics. I love the part where he was like, oh, the mathematics aren't that hard. I was like, you are literally the only one in the room who thinks so.
Yes, it was.
So
went by all too quickly, but
yes.
I think we packed a lot into that. Slightly longer than an hour there. Yes, that was good.
Yes, so that was great. I want to again thank Todd personally, and for all of us here at AVRant for taking the time out of his busy schedule to talk with us. I know he's got a lot going on, and certainly he did research specifically to answer questions on our podcast, which kind of blew me away a little bit. I was like, dude, you can off the cuff this stuff, because I know I do. But it was really, really great talking to Todd. Any last thoughts, Rob?
The man knows whereof he speaks. That is clearly the reason he did that research. He wants to make sure that he gets it absolutely right. There were definitely things that Tom and I learned, which is wonderful. That is what it's all about, because if we're learning things that allows us to provide better information to people who are asking us questions, I absolutely love that. It's going to change slightly, some of the recommendations that I've been giving out regarding dual subwoofer placement and setup and that. And that is exactly what we want. We want to take the evidence and the research that is being done by people smarter and more capable than Tom and I and say, hey, that makes a lot of sense. Thank you for showing us that information, and now we can provide better information to our listeners. That is what it's all about. Love that, and very, very beneficial.
The last thing we're going to do in this podcast is dig our heels in and decide that what we know best. So if Todd says it, and you could even hear in his responses that he's still learning.
Absolutely.
He's still open to learning.
Completely.
He's not saying he's an expert and that he knows all the answers, and that's the mark of somebody that you should trust. That's somebody that you should listen to. When somebody says, based on my experience, this is what it is, but there might be other things out there that I'm not aware of, and I'm okay with that. And that was really great. So certainly somebody to learn from, certainly a pleasure to speak to, and I can't wait to have him back on the podcast. Once again, if you would like get your questions answered on this podcast, all you do is ask. You ask by emailing us at question@avrant.com, and we'll be happy to answer them for you. And I very much look forward to having Todd back on the podcast. I might just drop Rob and have Todd be the co-host from now on. Sorry, Rob, you're fired.
Yeah, it could be. If he's able to bring Sean Olive along, like he mentioned, that would be fantastic. And we don't need 4 heads. 3 would do.
Oh no, we need Rob. I can't do this by myself. Come on, Rob. You're invaluable around here. For AVRant, I'm Tom Andry.
And I'm Rob H. Now stay in and listen to something.
Want your question answered? Send it to question@avrant.com.
Let it go.
This is AVRant.
Now go out and listen to something.